Welcome all for Security and Privacy in Cloud. And I am Lavanya, Assistant Professor of CSE Department. So in this Unit 2, Security Design and Architecture for Cloud, we are going to discuss on the topic tokenization, obfuscation, PKI, and key. So the first one is that tokenization. So tokenization is the process of converting some sensitive data into some non-sensitive data like replacement, which is called as a token that maps back to the original. So tokenization mainly it helps to protect some sensitive information. For example, like sensitive data can be mapped to a token and placed in a digital vault for secure storage. The token then act as a secure replacement for the data. The token itself is a non-sensitive and has no use or value without connection to the data vault. So, but before that, so what is meant by token, right? So token in general, it's a collection of characters that serve as an identifier for some other asset or piece of information. For example, one could replace an annual expense figure of USD dollars like 45,000, 500,000 in the confidential report with the token of some 0T, ampersand 14%, something like that. So token also appears in non-language processing, and also there are different types of tokenization. So what are the different types of tokenization is that first one is that irreversible tokens and reversible tokens, and then format preserving tokens. So what is meant by irreversible token? So irreversible tokens are just that, tokens that cannot be converted back to the original value. So irreversible tokens are often used to normalize data, and then which enables the tokenized data set to be used with third-party analytics or in less secure environments. And reversible tokens, it can go through some de-tokenization to be converted back to the original data values. And reversible tokens are useful when people and system need access to the original data. For example, when issuing a refund payment, processor might need to convert a payment token back into the actual payment card details. And last, the format preserving token. Here, it has the same format as the day they replace. For example, the token for a credit card number, the format say 1234, 1234, 1234, 1234 might be like 8493975619866455. So the format preserving tokens support some business continuity because they help to ensure that a data structure remains the same even when tokenized. So this stable structure makes the token more likely to be compatible with more traditional and updated software. Payment system that uses tokenization to protect sensitive information can have high and low value. The high value token can replace a primary account number in transaction, enabling to complete the transaction by itself. The low value token like substitute for parents but are not allowed to complete the transaction. So the low value tokens must map their valid path. So this is the example for it. Like there will be original cardholder data. The last name is that Doe and first name is Jane. In account number, they have given something like this, and a telephone contact. If by means of tokenized cardholder data, we could not able to see the original data, right? So here the last name will be something like it will be a software type, and here also something like that. Account number also something like this, and telephone contact also be like this. So no one can understand, right? So this is how an example here how this particular tokenization, so this step the original to this particular process, how it's converted. Let's see. The tokenization system often includes the following components: token generator, token mapping, token data store or token vault, and then last one, encryption key manager. The first one, token generator. So token generator here that creates tokens through one of the several techniques Like these techniques can include different functions like mathematically, a reversible cryptographic function that use powerful encryption algorithms that can be reversed with an associated encryption key. And second one is that one-way or non-reversible cryptographic function such as hash function. A third one, a random number generator to create random tokens, which is often considered one of the strongest technique for generating token values. And second one, the token mapping, right? The token mapping, what they mean is that it processes that assigns a newly created token value to the original value. A secure cross-reference database is created to track the association between the tokens and the real data. This database is kept in a secure data store so that only authorized users can able to access it. And third one, the token data store or the token vault. Here, it holds the original values and the related token values. The data that is stored in the vault is often encrypted for greater security. The vault is the only location where a token is connected back to its original value. And last one is that encryption key manager. So here the encryption key manager to track and secure any cryptographic keys which is used to encrypt the data, the vault tokens in a transit or other data and assets in the tokenization system. So tokenization without a vault is also possible. Rather than storing some sensitive information in the secure database, vaultless tokenization uses some encryption algorithm to generate a token from the sensitive data. The same algorithm can also be used to some reverse the process, like turning the token back into the original data. And most reversible tokens do not require the original sensitive information to be stored in a vault. When a third-party tokenization provider is used, the original sensitive data might be removed from an enterprise's internal system and it is moved to the third-party storage and replaced with the tokens. So this substitution helps to reduce the risk of data breaches within the enterprise. The tokens themselves are typically stored within the enterprise to streamline the normal operation. Okay, so an example of tokenization is that to make an account on an official government website, a user must enter the SSN, right? And second tokenization, the website just sends the SSN to tokenization service. Thereby, the tokenization service generates a token that represents that particular SSN number, which is commonly used in US. Okay, like SSN social security number, like as we have the other number, they'll be having like social security number. And here, and the tokenization generates represents the SSN, stores the actual SSN in a secure vault. And the tokenization service sends the token back to the website. The website stores only the non-sensitive token. When the website, suppose it needs to access the original SSN, for example, to confirm the user identity during the some later visit, or if I just close that particular system, if I want to use it again, is that it sends the token back to the tokenization service. The service matches the token with the correct SSN in the vault to confirm the user's identity. Okay, and like what are the use cases and the benefits of tokenization is that the benefits of tokenization is that it can bring extra data protection, okay, to many types of data across many industries and business functions. And before going for this obfuscation, it also has so many advantages, which I'll discuss in the last one. So what is the obfuscation is that it means to make something difficult to understand. Programming code is often obfuscated intellectual property or trade secrets and to prevent an attacker from reverse engineering a proprietary software program, encrypting some or all of the program's code in one obfuscation code. Okay, so here encrypting some or all of the program's code is one obfuscation method, and other approaches include striping out potentially revealing metadata, replacing class or variable names with a meaningless label, and adding unused or meaningless code to an application script. A tool called an obfuscator will automatically convert the straightforward source code into a program that works as intended but is more difficult to read, understand, and therefore compromised by potentially malicious parties. Okay, so unfortunately, these kind of malicious code writers, they also use these methods to prevent the attack mechanisms from being detected by an anti-malware or antivirus tools. And so these is known as obfuscation. And what are the obfuscation things? So before going to this topic, we have to just say why we use the code obfuscation. Okay, so obfuscation in computer code, which uses some complex roundabout phrases and redundant logic to make the code difficult for the reader to understand, while maintaining its inherent functionality. So the reader might be a person, okay, or a computing device or another program. So here the goal is to distract the reader with a complicated syntax and make it difficult for them to parse the message and determines its true content. The code is too complex to understand, it becomes harder to reverse engineer the application, right? So once you can't understand, you don't skip that particular code, right? So that they'll be using some obfuscation. Okay, so obfuscation is particularly important to protect the application from being compromised by an unauthorized or malicious parties. For instance, a cyber criminal might be looking into some understand the application's logic for numerous purposes, such as cloning the application or to root or crash a system or to compromise some sensitive data, okay, or to modify the code to change the application's functionality or output. Okay, so obfuscating the code also makes it harder for the threat actors to exploit vulnerabilities in the application in order to install malicious code, escalate the privileges, and initiate some denial of service attack or hijack the user's session. Okay, finally, it prevents attackers from trying to deceive the users into some revealing sensitive data such as financial information or personal information and all those stuff. Okay. So how does obfuscation work, or the code obfuscation work is that, for example, if I have a code called where a is equal to hello world and a is equal to 10 and where a product is equal to a into a. So this will be in turn, it will be declared as wars is equal to 0x154 is equal to 9834 something, whatever like random numbers will be generated. So that is a sample form of obfuscated code. So obfuscation might involve some changing the content of a original code by adding some dummy code, renaming the variables or changing the logical structure, replacing some simple arithmetic expression with a complex equivalence, and so on. But even with these changes, obfuscation does not alter how the program works. Neither does it modify its end output. Rather, its main purpose is to make reverse engineering difficult. So that is the main keyword here. Okay. So obfuscation, different programming languages, it is compiled like C Sharp, Java. Okay, it is more difficult to obfuscate because it compiles a machine code, which is more difficult for the people to work with. Okay. So, and also for decompilers to reverse the compiled program code. And however, when the code is obfuscated, the decompilers cannot work as well, preventing the advisors from automatically reverse engineering the source code written in that language for that OS or using that development platform. Okay. So, what are the obfuscation techniques? It uses some different methods often. Multiple techniques that are used to create a layered effect. In fact, it is recommended to use more than one obfuscation technique because there's no single silver bullet to avoid cyber attacks involving some application reverse engineering or some code theft. Okay, so we can use multiple techniques better, which harnesses the code and provides a high level of protection to safeguard the sensitive data and prevent application reverse engineering. So the first one is that renaming, packing, control flow, instruction pattern transformation, arithmetic and logical expression transformation, dummy code insertion, metadata or unused code removal, binary linking, opaque predicate insertion. Okay, so the first one, renaming. So what does it mean by renaming is that this is one of the obfuscation technique. So this obfuscator alters the method and names of the variables. So we can rename, just change the name of the file. Here we have seen in Excel or Word, something like that. So the new name might include some undecipherable or unprintable or invisible characters. So this method is commonly used with Java, Android, .NET application, and iOS. Okay, and what is meant by packing? So what is meant by packing is that this compresses the entire program to make the code unreadable. Okay, so what is meant by control flow? So control flow, the code's logical structure is changed to make it less traceable. Decompiled code yields non-deterministic semantic results and is made to look into some super logic. Okay, and this logic is unstructured and therefore hard for a hacker to understand or take advantage of. And next one, instruction pattern transformation. So what is meant by instruction pattern transformation is that here this approach takes common instructions created by the compiler and swaps them for more complex or less common instructions that effectively perform the same operations while also hardening the code. And next one is that arithmetic and logical expression transformation. So here, this simple arithmetic and logical expressions are replaced with some complex equations that are hard to understand. Okay, and then dummy code insertion. So dummy code which can be added to a program to make it harder to read and reverse engineer. Like the other obfuscation methods, does not affect the program's logic or outcome. Okay, and next one is that metadata, which you might have seen in the DBMS. I think metadata is nothing but data about data in DBMS, right, or on use code remote. But here the metadata provides some extra information about the program, much like annotations on a Word document that can help readers to understand its content, history creator, and so forth. Okay, removing metadata as well as unused code leaves a hacker with less information about the program and its code, reducing the likelihood that they will be able to understand its logic for reverse engineering purposes. And this technique can also improve the application's runtime performance. Okay, and next one, binary linking. So what is meant by binary linking is that it combines multiple input executables or libraries into one or more output binaries, which reduces the amount of information available to cyber criminals for possible application or exploitation. It also makes the application smaller and simplifies its deployment purpose. And next one is that opaque predicate information. So opaque, transparent, you might have seen like in physics, like opaque, you can't able to see that particular what is happening inside it. So a predict in code is a logical expression that's either true or false. Opaque predicates or conditional branches or if-else statement where the results cannot easily be determined with statistical analysis. So inserting an opaque predicate introduces some unnecessary code that is never executed but might be puzzling to someone trying to understand the decompiled output. Okay. And some more techniques are there, that is string encryption and code transposition. So string encryption is that the method some uses some encryption to hide the strings in the executable and only restores their values when they are needed to run the program. This makes it difficult to go through a program and search for a particular strings that said like decrypting the strings at runtime can adversely impact the runtime performance, although the effect is usually quite small. And code transposition is the reordering of a routine and branches in the code without having a visible effect on its behavior. So these all comes under the uh, obfuscation technique. Okay. So tools that are available to better secure application from code reversing. One example is that anti-debug tool, and like other methods like anti-tamper tools. And so here these kind of tools will be detecting the code that has been tampered and it will stop the program from executing further. It can also shut down the program or limit its functionality to prevent compromise or activities that might affect data integrity. However, the hackers can also use these tools to reverse the engineer code. And this anti-debug tool, what they will do is that it enables the IT security pros to identify when a hacker is running a debug program and as part of an attack, stopping their reverse engineering attack and other malicious actions. Okay. So before going for the advantages of obfuscation, we will discuss about how to measure the obfuscation success. Okay, can be measured based on the three criteria. First one, strength. Second one, differentiation, and third one is that expense, and fourth one is that complexity. We used to call like short form SDEC. Okay, so S for strength, D for differentiation, E for expense, and C for complexity. So strength, to which extent the transform code can resist automated deobfuscation to attempt to determine its strength. The more effort, time, and resources it takes to indicate the strength of a code, and efficiency or differentiation is that the degree to which the transformed code differs from the original is another measures how effective it is. So two ways there are to judge the differentiation. The first one, the number of predicates in the code. The next one, the depth of inheritance tree is a metric which is used to indicate the complexity of a code. The higher the DIT means the more complex the program. Okay. Expense, we know that a cost efficient obfuscation method will be more useful than an expensive method, particularly if it scales well for some larger application. The complexity, the more layers the obfuscator adds, the more complex the program will be and making the obfuscation more successful. So what are the advantages is that secrecy, efficiency, and then security. Okay. So what is meant by secrecy? So secrecy is that obfuscation hides the valuable information contained in code. This is an advantage for legitimate organization looking to protect the sensitive information and guard from competitors and attackers. On the other hand, bad actors also capitalize on secrecy facilitated by obfuscation to hide their malicious code, evade the security tools, and launch some successful cyber attacks. And next one, efficiency. Some obfuscation technique like unused code to remove some shrink the program and makes it less resource intensive to run. Okay. So security. So obfuscation is a built-in application security method. Sometimes it is referred to as an application self-protection. Instead of using an external security method, it works within what's being protected and the application code to prevent some unauthorized access. It is well suited for protecting applications that run in an untrusted environment and that contain sensitive information whose loss can be catastrophic to an organization or a user. So these are the advantages of obfuscation. And next one is that the disadvantage or the drawbacks of obfuscation is that here one of the main drawbacks is that code is more difficult to read for an internal developers. For example, like code that uses the string encryption obfuscation method, it requires a decryption of the strings at runtime, which slows the performance. Okay, so another drawback is that it can be also used for some malicious purposes. One example is to initiate malware and virus attacks. With obfuscation, instead of developing a new malware, threat actors repackage commonly used commodity attack methods to disguise their features. In some cases, they include vendor-specific techniques to improve the probability of success. And next one is that the malware authors, they'll be using some obfuscation to fool and evaluate some antivirus tools other than cybersecurity programs that which relies heavily on the threat signature to identify the threats. So these programs typically interpret the code and scan it for the specific features that indicate if the program is malicious. Okay, and the threat actors might use some deobfuscation technique to undo the obfuscation. These techniques include program slicing, which includes narrowing the program code to just relevant statements at a particular point in the program. And then public key infrastructure. So here the PKI and it uses some on campus is everything which is used. So we'll discuss about the PKI in the upcoming slide. It also used to create, distribute, the manage, store, and revoke the digital certificates. And a digital certificate cryptography, it links a public key with the device or user who owns it. This helps to identify the authenticate the user and device, which ensures the secure digital communication. So these all comes under the disadvantages of obfuscation. The next topic is that PKI and the key. Okay, PKI is nothing but public key infrastructure. Okay, so what is meant by PKI? So PKI is an important aspect of internet security. It's a set of technology and processes that make up a framework of encryption to protect and authenticate the digital communication. So PKI is also uses some cryptographic public keys that's connected to a digital certificate, which authenticates the device or user sending the digital communication. Okay. So the main thing is that a PKI protects and authenticates the communication between the servers and the users, such as between your website, or it may be between a client, to connect through the browser. It can also be used for secure communication within an organization to ensure that the messages are only visible to the sender and the recipient. They are not tampered with in transit. Okay. So how does the PKI works is that the main component. So there are, before working on the PKI, we will discuss on the component which is involved in PKI. First one, certificate authority. Second one, registration authority. And next one is that certificate database and central directory and certificate management system, and then certificate policy. Okay, so what is this certificate authority we used to call as a CA? That's the standard format. It's a trusted entity that issues, stores, and signs the digital certificate. The CA signs the digital certificate with their own private key and then publishes the public key that can be accessed upon request. And registration authority is that the RA verifies identity of the user or device requesting the digital certificate. This can be a third party, or it can be accessed upon request. And registration authority is that RA, it will be just sorry, certificate database. The database stores the digital certificate and its metadata, and also it includes how long the certificate is valid. Okay, and then central directory. Like central directory is that here, this is a secure location where the cryptographic keys are indexed and stored. Certificate management system is that this is a system for managing the delivery of certificates as well as access to the certificate policy. Here, it outlines procedures of the PKI. It can be also used by the outsiders to determine the PKI's trustworthiness. And here, how does the PKI work system? The public key infrastructure uses an asymptotic encryption method to ensure that the messages remain private and also to authenticate the device or user sending the information or the transmission. And asymmetric information uses both public and private key, right? So they're here, the public key is available to anyone who requests an issue from the trusted certificate. Like as I told, there's a component for CA, right? The second component, like I told, like registration authority or the certificate policy, central directory, certificate database. By means of that, this key will be kept private by the recipient of the encrypted message and used to decrypt the transmission. And complex algorithm are used to encrypt and decrypt public or private key pairs. The public key authenticates the sender of the digital message, while the private key ensures that only the recipient can open and read it. Okay, so this is all about how does the PKI works. So this is the structure of the PKI. So here you can see the certificate will be shipped from the communication partner A, that it can contain public or private key. By means of that, the certificate authority will be issuing the CSR file, and CSR, the public key, will be going to the registered field, and from there the certificate revocation list will be considered, and based on that it will be validated, and the validation will be done on the receiver side. Okay, so this is all about how does the PKI works. So what are the components of PKI? We have already seen. certificate authority, registration authority, certificate database, central directory, certificate management system, as well as certificate policy. Next one, PKI certificate. So here, in this PKI, the core of the public key infrastructure is important in the recipient entity to know without a doubt that the center of the digital certificate is exactly who they claim to be. The trusted third party CA can vouch for the sender and helps to prove that they are indeed who say they are. And digital certificates are used to verify the digital identities, and digital certificates are also called as a PKI certificate, or we used to call as a X.509 certificate. I hope you might have heard this term, X.509. So for each and everything, there is a separate structure which is involved, X.509 or PKI certificate. Okay, sorry, this is a 9. Okay, yeah. So here, this X509 certificate, it offers a proof of identity to a requesting entity, which is verified by a third party and works like a digital passport or a driver's license. So in that particular certificate, what will it will contain is that a distinguished name of the owner and owner's public key, a date of issuance, expiration date, and then distinguish name of the issuing certificate authority and issuing certificate authority's digital signature. Okay, so all these things it will be containing. And next one is that why the PKI is used. So why we have to use this PKI certificate is that one of the most commonly used of PKI is the TLS or the SSL certificate used to say. Okay, so why we have to using is that TLS or SSL certificate or transport layer or secure socket layer we used to say here, which secures some encrypted HTTP hypertext transfer protocol communication, and website owner will obtain some digital certificate from a trusted CA. So to be issued from the certificate authority, the owner of the website has to prove that they are indeed the actual owner. For that, if they need to purchase a SSL or TLS certificate, they have to themselves they have to prove that they are the owner. So once the issue has been verified by the particular website owner, they can purchase SSL certificate to install on their web server. This tells the browser that is the legitimate website the browser is trying to access. Okay, and this TLS and SSL protocol or SSL layer, it really where the user has to trust, the root certificate granting authority. An alternative scheme is the web of trust, which uses some self-signed certificate that are validated by a third party. A web of trust is often used in smaller communities of users, such as within an organization or self-contained network. And additional uses of PKI include the following, like email encryption and authentication of the sender, signing documents and software, using database servers to secure some internet communication, and next one, securing the web communication such as the e-commerce, and next one, authentication and encryption of documents, and securing the local networks and smart card authentication, encrypting and decrypting the files, and restricted access to VPN and the enterprise intranet, and secure communication between mutually trusted services such as IoT devices. Okay, so these are the additional uses of PKI. So what are the types of open source PKI is that it is publicly available. You can able to download in a free usage. So first one is that EJBCA enterprise. So EJBCA enterprise is that here uh, is developed by Java as an enterprise grade or fully featured CA implementation, and it can set up a certificate authority as a service or for internal use. And second is that OpenSSL. It is a commercial grade full feature toolkit that is included in all major Linux distribution and it was developed in C language. It can include some PKI enabled application and be used to build a simple C and CFSSL. This is a Cloudflare PKI or SSL toolkit for signing, verifying, and bundling TLS certificate and building the custom TLS or PKI tools. And next one is that XIPKI. Here it's a high performance, highly scalable certificate authority and OCSP responder. And this is implemented in Java with SHA-3 support. SHA-3 is nothing but it's a what is that? It's a hashing algorithm. Okay, last one is that a dog tag certificate system. So this is an enterprise class full feature certificate authority which supports all aspects of certificate lifecycle management. Okay, I hope these are the types of OpenSeas PI. So, but other than that, there are so many open sources available. So the main, like if you take the applications of PKI is that here it is used in some email, web, IoT, or for tracking the data. Okay, there are so many things available. So the main applications of thing is that it's a common method which is used for transforming the data for devices to password, user authentication, or wireless network authentication. Okay, so that is why if you take this, most probably they'll be using these kind of PKI. Okay, and apart from that, it is also uses some digital identity validation website, and it will also use user authentication, wireless network authentication, VPN authentication. So here that we can have the what is that? We can select the option called the particular or certificate. And next one, email server authentication, like displaying the verified company logos in email inboxes. Okay, so Chase, like Amazon, they'll be using some standardized format. Okay, and it's a sensitive information, all those things. Okay, so we have seen and discussed on the topic like public key infrastructure, and then so what are the uses, what are the advantages of public key infrastructure, and then obfuscation, and how to where it is used and where kind of languages and use cases they are using. Okay, and what is meant by tokenization and what is meant by tokens, and all those stuff we have seen. So thank you all, we will see in the next video. Bye.